Hello and welcome to this tutorial. I'm Gerhard Gabmeier, the author of the OPC UA Dissector for Wireshark. Wireshark has supported the OPC UA binary protocol for about a decade, which has been essential for developing our UA products. However, one key feature was missing: support for decrypting encrypted OPC UA traffic. This has changed now, and if you are looking for how to decrypt OPC UA traffic, this video is for you. OPC UA has supported secure encrypted communication from the start. While great for security, it can complicate troubleshooting, especially in real-world factory environments where you can't just disable encryption. To address this, I implemented UA decryption support in Wireshark, which was included in the recent Wireshark 4.4 release. Before diving in, let's cover the basics of the UA binary protocol. After the initial UA TCP handshake, UA clients establish a secure channel using the Open Secure Channel service, which is asymmetrically encrypted with RSA. Decrypting this would typically require the server and the client private keys, which isn't practical. Fortunately, this service exchanges random nonces to derive symmetric AES keys, which are then used to encrypt subsequent services. If we get this key somehow, we can decrypt all symmetrically encrypted traffic. Our SDKs can lock these symmetric keys to a file when KeyLogging is enabled. Wireshark can then use this file to decrypt the UA protocol, except for the Open Secure Channel service. Installing Wireshark. Windows users can download Wireshark from wireshark.org. Linux users can install Wireshark using the distributions package manager. Make sure to use version 4.4 or later. If it's not available in your distribution, you might need to build it from source. For this demo, I'll use the high-performance SDK 1.8.1. I have already installed the SDK sources and will use the builder's script to build it. To speed up the process, I'll disable the unit tests and build a server-only profile. The keylogging feature is off by default, so that nobody can accidentally deliver this feature without knowing. I'd enable it in the CMake GUI by searching for keylogging and then regenerate the build files. After rebuilding, the feature exists in the binaries but still is disabled at runtime. I enable it by creating the OPC UA keylog file environment variable, which specifies the path for the log file. When starting a demo server with this variable, it will log the symmetric keys for each secure channel. Now it is time to start Wireshark and capture one session. I'm using the loopback device to capture local communication only and use the capture filter TCP port 4840 to capture only UA traffic. Now I'm using UaExpert to connect to the server. After capturing traffic, Wireshark still shows encrypted services because it doesn't have the keys yet. To fix this, I go to the OPC UA protocol settings in Wireshark's preferences and specify the path to the keylog file. Now the services are decrypted and we can inspect their contents as usual. Managing multiple capture files and keylog files can quickly become cumbersome. To streamline this process, you can inject the keylog file directly into a capture file. This way, whenever you open the capture file, Wireshark can decrypt the traffic immediately without requiring a separate keylog file. This method is also helpful when sharing capture files with colleagues or support teams, ensuring they can decrypt the traffic without needing the original keylog file or fiddling around with the preferences. Thanks for watching. I hope you found this tutorial helpful. If you have any questions or need further assistance, feel free to reach out. Happy troubleshooting!